It is 4:30 in the morning. A critical production database suddenly goes offline. The outage follows a specific, known engineering change, a variable altered just moments before the crash. For the next 4 hours, the on-call team scrambles in the dark. They dig through hundreds of alerts and system logs, trying to pinpoint the root cause of the crash, but they find nothing. Then, at 8:30 in the morning, the shift changes. The engineer who made the error logs off for the day. Before leaving, they drop a vague hint in the team chat about a variable they modified earlier. The morning team spends another 2.5 hours deciphering that simple hint. They finally resolve the issue at 11 a.m. Total downtime, 6.5 hours. Look at the catastrophic paradox of this timeline. The exact information needed to end the outage in 30 minutes existed in that first engineer's head at 4:30 a.m. Those 6 hours of wasted downtime resulted from a behavioral failure driven by fear. That vague hint left in the chat represents a calculated compromise. It balances an engineer's overwhelming guilt against their basic instinct for self-preservation. We call this the panic calculation. In the seconds after the database crashed, that engineer mentally weighed their options. They balanced the high personal cost of immediate ownership against the low personal cost of leaving a quiet breadcrumb on their way out the door. If the engineer had escalated their mistake immediately at 4:30 a.m., the timeline would look like the left side of the screen, a rapid 30-minute resolution. Instead, the team followed the right side, hours of cascading, wasted effort. The engineer makes this calculation because of deep historical conditioning. 20 years of traditional schooling, combined with previous toxic work environments, teach employees that hiding gaps and feigning certainty is safer than revealing a mistake. We should adjust our judgment here. That engineer acted with high rationality. Smart people operating within broken, punitive systems produce these compromises to protect themselves. This leads to a core management principle. You cannot force people to change their basic human nature, but you can change the environment that dictates their behavior. In a low-trust environment, a culture of blame forces employees to fight gravity, expending energy defending decisions. In a high-trust environment, the slope reverses. Admitting mistakes is safe, allowing the team to slide forward, focusing entirely on rapid problem-solving. An organization built on blame never prevents errors. It guarantees that those errors will remain hidden until they compound into uncontrollable, expensive disasters. Change in that environment requires changing how leadership reacts the moment a crisis hits. One panicked, angry reaction undoes months of safety building. This diagram maps out the systemic solution, the 24-48-week system. This framework mechanically separates immediate triage from long-term accountability. In the first 24 hours, focus entirely on containment. What is broken, and what resources do we need to fix it? You ask 0 questions about who caused it or why it happened. Only after emotions have settled and the fire is out do you move to the 48-hour mark. This is when you ask the delayed why to uncover what early warning signals the team missed. Finally, 1 week later, you address capability building. Structural changes, training, and process updates happen here, once leaders see broad patterns instead of just the isolated problem. This buffer is what makes the information honest. By forcing a delay between the incident and the investigation, you ensure the responses you receive are accurate rather than defensive. Implementing a framework is the start, but leaders must also publicly celebrate the speed of ownership. This survey of manager responses shows exactly what that looks like, explicitly thanking engineers for their honesty and early accountability. When one person is publicly thanked for bringing an error to light, it creates a cascading protective effect. In the Swiss cheese model of risk management, disasters happen when holes in safety layers align. But that public thanks acts as a solid plate that slams down to block future failures from aligning. Somewhere on your team, right now, an engineer is running the panic calculation about a critical flaw. Whether they choose to warn you or leave a devastating 6-hour hint depends entirely on how you reacted to the last person who told you the truth.